Hello, Azahari. Today we are going to present about the steam electric power station, which is using R134A as a cooling medium. So we are group number 23, and our group members are Pai Jun Jie, Mohamad Azam, Manarina Aina, and me, Ahmad Irham. So next I will proceed to introduction and background. So the steam power plant is widely utilized around the world to generate electricity, and coal is often used as a fuel. However, there is a negative effect due to largely used technology to produce electricity from coal. Hence, to improve the efficiencies of coal to electricity technologies, the thermodynamic performance will be examined. So that's all from me. Next, I will pass the floor to Pai Jun Jie.
Thank you, Irham. I will explain about process description and calculation. The power plant utilizes water cycle in a closed loop. Water passes from state 1 to state 2. It flows through the turbine to generate electricity. From state 2 to state 3, the generator releases heat. Then the water flows from state 3 to state 4 to the condenser, where it interchanges the heat with the R134A. From state 4 to state 5, the water passes through the pump, where the pump generate work for the continuous of the water cycle. From state 5 to state 6, the regenerator absorbs heat before flowing to the boiler. At state 6 to state 1, the water is absorb heat from the coal to boil before going to the turbine. The process is end from state 1 to state 6. Next slide. From the calculation we get, the efficiency of turbine is 43.2%. As we assume, 1 unit of turbine able to generate 46 megawatt out of 50 megawatt. So we utilize 7 turbines. The efficiency of regenerator is 45.6%, and the backward ratio we get is 3.1%. The backward ratio is relatively small, hence it is a good model of the steam power plant. Next, I will pass my part to Azam.
Thank you, Pai Jun Jie. Now I will continue on the justifications and recommendations. Our steam power plant is modeled after the Rankine cycle. We chose Rankine cycle because it is the most widely used cycle in thermal power plants. Operating condition at turbine inlet exceeds the critical point of water, which is at 373.95 degrees Celsius and pressure of 22,060 kilopascal. So the power plant is a supercritical power plant. We use supercritical power plant because it is more efficient than a subcritical power plant. The reason for this is that in a supercritical boiler, the compressed liquid changes directly to superheated steam once it passes the critical point, thus eliminating the need for heat of vaporization during phase change. Next slide. The fuel source that we have decided to use is anthracite coal. The reason is because anthracite has a high energy density of 33 megajoules per kg. For comparison, other types of coal have lower energy densities such as lignite with 18 megajoules per kg and bituminous coal with 27 megajoules per kg. Next, anthracite has a low sulfur content, around 0.6 to 0.77% by weight. This will reduce the air pollution caused by the power. Finally, anthracite has a high carbon content, meaning it will burn cleanly, emitting only a small amount of toxic substance while burning. Next slide. There are 3 recommendations which have been identified that can increase the efficiency of the power plant. First is to direct the flue gas from coal combustion in boiler to the regenerator so that some of the heat can be transferred into the water cycle, reducing heat loss to the surrounding. Second is to use biomass as fuel source instead of coal. Biomass is a renewable form of energy, while coal is non-renewable. Biomass also introduces less pollutants into the atmosphere during combustion compared to coal. The third recommendation is to continuously observe and properly maintain all of the engineering equipment involved to reduce energy loss due to things such as leakage and fouling. For the next part, I will pass it to Manarina.
Thank you, Azam. I'll be talking about the conclusion. So the model our power plant was adhered to is the Rankine cycle. In our power plant, 7 units of the Campro Waja TRL-12 turbine are used to produce the desired output work, which is 322 megawatts. We utilize an isentropic pump from state 4 to 5 that undergoes an internally reversible process. Then at the regenerator, isobaric reheating was involved from state 5 to state 6 to preheat the water before entering the boiler. Lastly, most of the heat from the turbine is conserved to avoid the water stream at the turbine outlet from getting overheated and to avoid heat loss to the surrounding. Because if the power plant system was badly insulated, the operation may break down and thermal pollution will occur. That's all from us. Thank you.